Okay, so here is our binary tree example and our code example from that video that we shared earlier. Um, so this code is written in C++. C++ is different from Java because it's going to include more details. There's a lot more things that you have to code for in C++ compared with Java. It's kind of similar, like C++ is to Java as Java is to Python. Like Python is even a less detailed-oriented code than Java. It just does a lot of the things for you. In C++, it's super detailed-oriented. We need to know like where the memories. We need to kind of allocate memory. We need to set up pointers. We need to do all this stuff that Java just kind of hides for us. But one of the good things about C++ is they have these things like this. These are our pointers, and these are explicitly something that you have to code for. So Java kind of hides it, so it's hard for us to really know what's going on. But in C++, we have to do all these kind of little things, which is, again, it's good and bad. Okay, so what we're going to do here. So we've created a node structure. It's going to have some like pointers to the left or to the right, and we're going to also, they've also coded this kind of pre-order recursive function. So as we get started running the pre-order function, we're going to start with our root pointer. So we would run that, put the pointer into this pre-order function, and it's going to direct to our first node, which is going to be a node at the address 200. Okay, so what I want to do here is I want to look through our kind of stack frames. And I'm going to keep kind of copying and pasting this thing in there, because I think it's a good way of showing that like we keep kind of diving deeper and deeper and deeper. Okay, so in this first one, let's see. So the address here is going to be 200. So as we call this function, if this root was null, if this address at 200 didn't exist or there wasn't something there, we would return. So if that was if it had an address's value of 0, like it does down here, this thing would immediately close, and especially in the first stack frame, we would just go back to running the rest of the code, and we'd be done with our pre-order function. But of course, that's not the case here, because there is something there. So we are going to look through here, and we are going to find the first thing we're going to do is going to print the data. So let me keep track of the data out here. So the output of this data is going to first be F, because that's the first thing in the 200. And then we're going to go down to here, and we're going to pre-order root left. So what this means is, if we refer back to our node structure, is that each node is going to have a left and a right data. So we're going to check the left data, and we're going to find like the address on the left. Okay, that's 150. This is going to be our first. So again, we could say this is stack frame number 1. Now we have stack frame number 2, where we're checking out this left value. And I imagine this might probably will run out of room here pretty quickly. Same way we'll run out of memory. So in here, let's see, our address is going to be 150 this time. It's not null, so we will go into here, and we're going to print out D. Print the data, and then again, we're going to run pre-order left. So now we're in stack frame number 2. We are going to go run this again, so we need to have a whole other. Again, I think I'm going to run out of space really fast, but that's fine. And we'll open up stack frame number 3. In this case, now our address is 400. This is not null, so we're going to print out the data at, we're at 400 now, right? So we're moving on to output of B. And then we're going to check again. We're running into another, so we're going to run yet another pre-order. And in this case, we're passing in the value, what was it, for 400, so we pass in a value of 250. Okay, so I'm going to pause for there real quick and just say, like, okay, we can see already, like, stack frame 1, stack frame 2, stack frame 3, stack frame 4 are all kind of existing at the same time. Like, they are, well, like the name implies, they are frames. They're like sets of data that are stacked on top of each other. We have, because it's a stack, we have access to the very top layer, but there's all these other layers underneath. So all this data is still there. This still exists. We can still come back to it. The computer is just kind of like saving it for later. It's like if someone asked you to memorize a set of numbers and then kept talking to you, and it's like you have to keep those numbers in the back of your head while you're still listening to them. It's still there. It's taking up your memory in the back of your head, but that's not really what you're focusing on. It's kind of the same way with this. There's all this stuff that's kind of building up, building up, building up. Okay, so that's kind of, it exists. The data exists. It's still there. It's just kind of maybe paused or it's frozen in the background. With 250, okay, so we're going to print out A. And now we are going to have a root value of, as we get down here, this is going to be 0. It's going to be, well, null. As we run into here, our root is 0, it's null, so we're going to return. So it's technically stack frame number 5, but it's going to quickly exit. And at that point, we're going to return back into stack frame number 4. And now you remember, like we were listed these steps before, 1, 2, 3, 4. Now we're on to step number 4, and we're running preorder write. Okay, so preorder write, that's fine. We're still going to run the same thing. But now our, let's see, we're back up to this one, stack frame at address 250. Right? Wait, where are we at? 250. Oh, no, wait. 250. Oh, yeah, we were at 250. Oh, okay, yeah. Getting myself a little confused there. So this is technically stack frame number 6. This root's going to be 0, right? Because we're at 250. We're looking at the right address in that. Still going to be null. So we'll also immediately exit this and then return back to stack frame number 4. Now, technically, I don't know if you would. This might be stack frame number 5, then stack number 4, and then stack frame number 5 again. If you want to be technical, I would guess. But yeah, so now we run back to here. Okay, we close this so we can return back to the main function. And now that we have executed this entire, like all the code in here, we have run this entire function, we can exit out of this stack frame and return to stack frame number 3. Now again, I'll start over with num2, 3. We only got as far as 3, now we need to do 4. It's kind of like when we ran step number 3, or like check code line number 3, we got this whole big giant mess. So all that is just a part of line number 3 for this stack frame. Now we need to go in stack frame number 4. And let's see here. Okay, so we are, we're at stack frame number 3 and we're doing line number 4. This is for our node, I think it was 400. So going to the right, that's going to mean we have an address of 180. 180, the root's not null. We're going to print out its data, which is C. And then we'll do the left one. And as you can imagine, left one is 0. So this is going to be done. We'll return to here, and then we're going to run the right one. Again, this is going to be 0, so we'll return back here, and we'll be done with this one. And now, now we've closed all these stack frames. We're back to stack frame number 3. We've run all of stack frame number 3. Okay, now we're going back to stack frame number 2. Again, I can't help but think of Inception in this, and it's a really, maybe if you haven't watched it, you can watch it over break. Return to stack frame number 2. All these things have now finally finished. We're back to stack frame number 2. And again, we're going to go to the line number 4. Line number 4 from, let's see, our node was, I should have like overwritten that. I think it's, oh man, no, I can just check. It's 150. Now we need to check the right one. As we run preorder on the right string, we're going to open up this new node, and now this is going to be 450. And I mean, if you look at our code, we've like, let's see, which ones did we print off first? So like and what did we do first? This is 1, 2, 3, 4, 5. Return. 6. So we're into like this should be our 6th print. Yeah. So we're getting into it. We should be printing E here. Where are we at? We sent in 450, so we're going to this address. It's not null. We printed the value there. It's going to be E, and I'm not going to show these steps again, but you can see like the pre-order, the 0 value is, well, the left value is 0, the right value is 0, so these are both going to just immediately return. So we've completed this one. We can return back to stack frame number 2. This is going to close. We've run everything in here. Now we're returning all the way back up to our original root, and we're going to start on the other side of the branch. And that's where I'm going to leave it. I think we could go through the rest of the steps, but like that is, that's essentially what's going to happen for the other side. We print out. I mean, I think we can print out. We can kind of, based on our pattern here, we're going to print out like the root J, and then we're going to go to the left, print it out. And then here we'd go to the left, but there's nothing there, so we go to the right, and we come down and print I. We check left, check on this 500 address, we check left, check right, nothing there, return to the top, did right, did left, did right, return to the top, go right. Now we're going to print out K, check left, check right, nothing, come back up here, we check left, check right, come back up here, we check left, check right, all done. Whew. So that kind of code, I mean, what's beautiful about this code is that all of this is happening, all of these stack frames and checking all the way to the bottom of this. I mean, this could be a huge, giant binary tree. Who cares how big it is? We're going to look through the entire thing, using 4 lines of code. 1, 2, 3, 4. Doesn't matter how big it is, this is going to search through everything. So I think, for me personally, I just think that's so amazing to, like, 4 lines of powerful, elegant code is going to search this entire thing. I think there's some sort of, kind of just, I don't know, I just think it's cool, and I think there's a beauty in that, there's an elegance, I think it's really cool. Okay, so we're going to move on to our Inorder, and I'm not going to go through with this one as much detail. I guess I'm kind of repeating what was in the video. I think what I've added to what was the video content was the focus on. So yeah, what I think, my children were distracting me. Like a lot of dumping coins and yelling stuff, so it's always a good background for videos. Okay, so what I thought I added was that, like, a lot about, like, using stack frames to kind of explain this, and also I think, you know, seeing just the kind of getting all these programs or these kind of stack frames opening, and then kind of closing and collapsing, like expanding and collapsing. So that was kind of my focus. So I don't want to do that quite as much here, but I do want to just kind of look through these and just make sure we're kind of aware of, like, how these things are going to work a little bit different, the in order and post order. I won't go through all the detail here. I think the focus of the previous one was really strongly connect recursion with stack frames with the binary tree, and now we can look at, like, just kind of briefly look over this and see how it's going to work. Okay, we're taking in the root. If the root is null, return. Okay, so that's the base condition we're going to see across all of these. It's a way to, if we get down to a root that doesn't exist, or that there's not, or maybe not a root, get down to maybe a leaf that doesn't continue, we can return back up. So that's always going to be the first case. Now here, the difference here is we can see that we're not printing out the data right away, right? We're going to the left first, and then we're going to print the data, and then we'll check the right. So just these tiny little changes of where we're printing the data is all the difference, right? If we are doing in order, so that means, like, okay, well, let's look at this. As we enter this as our first data, the address at 200, or the node at 200, I guess, we'll do 150. And then it's going to open up a new, and actually, just for me personally, I'm going to do this just so I can kind of keep track of what's happening here, and I can not go through, like, super crazy detail. But, like, this is, I don't know if I'm going to do numbers. I'll do it for this first one. 200. Okay, so now this is going to automatically, because it's kind of hard in my mind to think through of, like, what the stack frames are doing and what the values are. Like, that this thing kind of pauses. This is a good reminder for me that this kind of pauses, and we open up a new kind of window. So we're looking through, yeah, what do we got now? 150. We got on 150 as a value here. Again, we're going to the left. We're going to get that 400. Again, we haven't printed anything yet. Again, we're going to the left. Let's see, and we're going to get 250 here. I'm going to go off the screen there. Again, we're going to go left, and that's where we're going to hit our A. That's when we finally get to something here where our left value is going to, where this, actually, I guess I'll just show that very last one. So we're at 250. We took in a value of 250. The root's not null. In order, root to left. So if we go to the left, it's null. So, like, this would technically open up another stack frame, but then it would immediately close it out and return here. And now finally we're going to print the value A. And then we're going to check the right. Nothing's going to be there. So we'll return to the top. And now we've completed all of this. So we'll move on to the next letter, B. And I think what are we at here? I think we're at this one now, right? Checking right, 180. We're going to go down to here. We're going to check left, nothing there. We'll print C, check right, nothing there. Return back up. We've done left, we've done right. We'll return back up here. We'll go right and go here. Check left, nothing. Print E. Did I miss a? Oh yeah, I did miss a letter here because we're at A, B, C, and then as we return back up to here, we did left. We didn't print right in there, so we missed the C down here. And then a D up here. Finally go right, nothing's left. We'll print E, nothing's right. We'll return. We've done left, we've done right. We'll go to back up. We need now to, yeah, I keep kind of skipping over the step. We've done left. We need to print the data, go right, go down, go left. Yeah, go left down to here. Left is nothing. G is there. We'll print G. Go right, go down, go left, nothing. Print the data, go right, nothing. Return up, done left, done right. Return to the top. Done left, print the data, go right, we'll come down to here, nothing left, print the data, nothing right, return up, let's see, we've done left, right, return up, done left, right, return up, and we're done. So that's what's going to print out here. So just kind of making that clear connection between that kind of, like, I mean, recursion is all about repetitious, and we're going to kind of go through each step kind of methodically, figure out like what's happening. I think as we practice with one, these other ones are a little bit clearer, hopefully. All right, diving right back into post order here. Let's just run it. We're going to start from the root. I'm going to actually draw the real pen on my board. That's not smart. Okay, so we're going to go into here. We start with start the address 200. And let's, make it a little bit smaller. Let's put that over here. We'll start with our address 200. It's not null. Oopsies. Not null, so we'll check left. Okay, so we're going to go left down to here. We're going to go down to, the next one over is going to be 150. All right, so we're taking in a value 150. We're going to go left again. So, I mean, the difference here is we're going left, and then we'll check left and right. We're not going to print anything till the very end. So we'll go left again. We'll get to 400. We're going left again. I'll kind of continue like this. I did last time. I'm not going to do every single last bit, but we'll at least get the starter here. Okay, so we get to 250. We're going to check left from there. That will open up a stack frame, but it'll immediately close. Same thing here, checking right. They're both null, so checking that will open stack frames. They'll just immediately close. And then here, printing the value here at A. So we're going to print A first. And then we've done left, we've done right, we've printed. We'll return back up to 400. And now we've done left, we need to check right. That means that we're going to go down to here. We'll find this value down here. We'll check left, we'll check right. Nothing will be there, so those will both immediately close. And then we'll return and we'll get C. Once these two have been completed, we return up here. We've checked left, we've checked right. Now let's print our data. Now this is done. We return up to the top. We've checked left. Let's check right. We go down to the right. Check left. Nothing there. Check right. Nothing there. Let's print E. Now as this finishes, we're going to go back up to the top. We print left. We've checked left. We've checked left. Check left. Print right. I still said it wrong. Check left. Check right. Print the data. Okay, we've done all that. Let's return up. We've checked left. Let's check right. We'll go down to here. We'll check left. We'll go down to here. Check left. Nothing. Check right. Go down, we're going to find I. Well, okay. Obviously, we go down here, go down to I, we check left, nothing, check right, nothing, print I, return back up to the top. We checked left, we checked right, let's print G. Again, we've kind of gone through all these values. Now we've checked left, let's check right. We'll go down here, left, nothing, right, nothing, we'll print K. And then return to the top. We've checked left, we've checked right. We can now print J. These all cancel out. Now we've checked left, we've checked right. Now it's time to print F. Okay, so hopefully it just kind of connects. I think it's really, just for me personally, in thinking about it and explaining it, like having the kind of the stack frames here and the code that's running is at least initially an important way to kind of get me started thinking about, okay, what exactly is going to happen on the computer. Once I know exactly what's going to happen on the computer, then I can start kind of being abstract about this and thinking through things a little bit faster. But for me personally, I need to know what the computer is doing first.